Hi again, welcome back. So this is going to be our first lesson in R for Health Data Science, and that is, well, what is data science? So I want to talk about some of the things that can scare people about a computing course. I'll briefly mention that a syllabus for this class exists for those of you who are actually taking this class for credit. And then I want to get into some different pillars of data science and talk about reproducibility versus replicability. And then we'll do our very first example in code a little bit later. So getting in, a lot of people are scared of computer code. Many people are scared of math, and then relatedly, they're often scared of computer code. Many times because the errors are confusing. You'll type a command in your computer and you won't understand why the computer's not doing what you're asking it to do or what you think it should be doing. And many times, let's be honest, a lot of computer programmers are not the most helpful, sociable people. Many people will, a lot of times historically, when new people try to learn a computing language and they ask for help in online forums, they're met with just like this blank stare of somebody just copying and pasting a text out of a user manual that honestly you probably already read anyway, and you're still confused. And people will say, well, why didn't you just read the manual? Why don't you just read and figure it out yourself? That's what I had to do, so that's what you have to do. I want to take that and just say, first of all, in this class, we're going to try as much as possible to meet you kind of where you're at and to say, okay, I understand that you may be having trouble with this, that this is very new material for you. A lot of times, if you're in public health, you have an undergrad degree in psychology or sociology or biology, maybe pre-med, something along those lines. You probably didn't get an undergrad degree in computer science, quantitative economics, statistics, or computational physics, computational biology, these things where you're constantly working with a computer anyway, particularly working with computer code. Most of you, if I say the word Java, you immediately think of coffee. Or perhaps you think of an island in the off on the other side of the world. But so the people that are trained in computer science, who are the experts that could help you with writing code, oftentimes they're not sometimes as open to helping people as I think that they should be. And that's not to say all of them, because there are some really, really fantastic professors in computer science that try to make learning computer science accessible. So anyway, for this class, we are going to try to work from a position where you kind of know how to do very minimal things in a computer, like pointing and clicking with your mouse and maybe installing a piece of software, something like that. And for those of you who are officially registered in the course, I will have Zoom office hours to help walk you through installing the software if you get stuck. As I mentioned in one of the previous videos, this on the first page, the home page, there are some links that will help you set up your computer, and those are very, very helpful. So again, the syllabus, if you're enrolled in the course for credit, you have access to Canvas and the syllabus is there. Primarily just understand that the grade for the class is going to come from 3 projects. The projects are honestly pretty intense. They're pretty tough, but they are as real as I can make them based on experiences that I've had consulting and working with real data, so that you kind of get experience working with data that does not look like the nice, pretty data sets that you've seen in many of your statistics or biostatistics classes up to this point. They are kind of ugly data sets. And for that, or by the end of the semester, they'll be ugly data sets. They start off pretty clean, but they do get much worse. All right, so data science. What is data science? And this is a definition I originally in an earlier version of these slides, I kind of just gave my own definition of data science. But then as I was rewriting this material earlier, maybe about earlier this semester, I realized that I probably need a citation here. So I went and found a paper that gives a definition of data science. So data science combines statistical methods, computational algorithms, and domain science information to extract knowledge and insights from big data and to solve complex real-world problems. Now, the way that I usually explain this is that data science is a building that has three pillars. So like you can think of like a triangle building or something, and there's a pillar here, a pillar here, a pillar here. And if you remove one of those pillars, the roof falls down. So we need all three pillars to make data science. One of the pillars is going to be statistics. Now, we're not going to be covering a whole lot of statistics in this class. I assume that you know how to calculate the mean. Just take the numbers and add them up and divide by how many numbers there are. But other than that, there's very, very little purely statistical concepts in this class. Now, that's not because those aren't important. It's just that if you're taking courses in a college of public health, you're already required to take 2 or 3 semesters of statistics anyway. So that means I already kind of assume that you know some of the things that you need to know about statistics, like how to do a t-test or how to do some basic regression, something like that. So data science, we've got our pillar of statistics, which I'm kind of assuming that you have some amazing professors in the statistics or biostatistics departments that are going to help you get that pillar for you. What we're more going to talk about in this class is this other pillar where we're going to put computational algorithms, and that's a fancy way of saying working with your computer, how to type and get the computer to do what you actually need the computer to do. So we've got these computational algorithms, super important. And a lot of times statistics and even some biostatistics departments, they don't focus enough on how do you actually interact with your computer. It's a lot of effort spent on learning mathematics and a lot of effort spent on maybe learning some calculus. And those are not wrong to learn. Those are very, very important to understand the statistical and biostatistical mathematical machinery of why we're allowed to be certain and why we're allowed to say that a 95% confidence interval is what it is, or what a p-value is, or that we could reject a null hypothesis. Those are important things. Those are foundations of science, the ability to make good decisions based on data. And I'm not disqualifying that. I have degrees in statistics, so I definitely appreciate those things. But the purpose of this class is to hopefully augment your skills in statistics with some of these computing skills so that you can interact with your computer and have your computer solve the problems that you can't do on your own, you can't do by hand. And that's what the computer is good at doing. The computer is good at doing very, very simple things very, very quickly. The computer is not good at doing complicated things. So for instance, if I ask you, make up a word, or make up music, or create art, or there's a comic strip called Calvin and Hobbes. And in the comic strip, there is a game that Calvin plays called Calvin Ball. And the point of Calvin Ball is to make up the rules as you're playing the game. If I asked a computer to do that, the computer right now, even with the advancements in artificial or virtual intelligence, it's not truly artificial intelligence yet, but virtual intelligence, ChatGPT, and so forth, it's very challenging for a computer to purely create things. But humans do it all the time. You can ask a 2 or 3-year-old to just imagine something for you, and they can create these humans can create from when they're very, very small. And it's almost a trivial exercise for them is to use their imagination and to create. So humans are very good at doing incredibly complex tasks, very hard, complex tasks. But we're not as good at a computer at doing very, very simple tasks very fast. If you ask a human, I want you to add, I'm going to give you a set of 4,000 randomly drawn numbers or something. Like here's 4,000 salaries from employees at this company, and I want you to add up all 4,000 of these salaries. A human is going to take at minimum a couple of minutes working on that. Even the fastest person, it's going to take them a while to add up 4,000 individual salaries at two decimal places. A computer, it takes less than like milliseconds, and they've already added up these 4,000 numbers. So a computer is good at doing simple things very, very quickly. And that's kind of one of the disconnects between humans and computers that causes this friction, where you're going to have humans that are good at complex idea generation tasks. But one of the difficulties that of getting into computational algorithms and computer science is to have you as a human start to think procedurally about what you do in order to give the computer the right instructions. And so that's what this computational angle is all about, is how do you get the skills so that you can start giving the computers what the instruction of what they need to know. And I'm going to rewind back up here, and I'm going to highlight this point. Computers give you what you ask for, not what you want. It's very important. And then finally, this third pillar of domain of data science is domain knowledge. All of you, as public health students, you take classes in global health, in health promotion, in health policy, in biology, in epidemiology, and all of these other things. And they're giving you the context of what does it mean when I record this particular feature on this particular person. This is the domain science, the domain expertise, this third pillar of data science that really makes that really makes the science move forward. And we need all three of them. We need to understand the data, and that's where the domain expertise, the domain science comes in. We need the statistics. We need to understand what the probability means. We need to understand what a confidence interval means. We need to understand what a beta coefficient from regression means. And then third, we need this pillar where we can interact with our computer. We need all three of them. All three are incredibly important, and all three together is what makes data science. So, and that's where I'm going to pause right here, is this to answer the question of what is data science. And in the next video, I'm going to get into the different components of data science.